In this video, we're going to talk about some handy troubleshooting commands. So, first of all, here we are in non-privileged mode. If you're in non-privileged mode, all you need to do many of the show commands is just type show, like question mark, and here's all the different options we have. So the question mark command is very useful. Show log last rows, which I have to tell a number. So I can put like 100, and that will show me the last 100 entries in the log file. That log file is also available in the Linux, but we'll show that one in a minute. Also, another very good one to use is show Ethernet switching interfaces. And those show me, if I hit enter, it shows me all the interfaces, what state they're in, whether they're tagged or untagged, and what the native VLAN is on a particular switch. So you can see here, like AE2 is up, it's tagged, and it has these VLANs on it. So that's actually a very useful command to be able to just take a real quick look at what your interfaces look like. The other one that I like a lot is show interfaces brief, because this shows me whether or not the port is up or down and what speed it's running at. Another one is show, and we've done this one a number of times. I can do a show. No, I can't do that one. In order to do this command, you have to actually be in the config mode. And then I can run, and you've seen me run this one before in other videos, show display set. And that shows me just the set commands that, I guess it shows me the configuration in set command format. So quite a few in that. If I'm in the non-privilege or the non-configuration mode, I would need to do a show running config display set. So that's, take my word for it, it's show running config, pipe into display set. And one other one that's actually very useful in case you're having problems and you need to contact support. Many times they will ask you for a show tech support. You'll probably want to turn off, actually this is just going to write this out to a file. Once it's done, I'll show you where that file's at here in a minute. It's still running, getting all the collected data, and then it's going to put it in a file that you will SSH off of the system. Alright, so when the command completes, it tells you exactly where that file's at. And in order to grab this file, I'll have to exit into the Linux. So we'll do a start shell sh. And then I can type more /temp. And I'm just going to cut and paste this in. And we hit enter. So this is a very long file. You can see I'm 0% and I'm still tabbing through it. So this collects a lot of information. So now that we're in this, I can cd over to /temp. You'll see the show support. I could then SCP this file to a local system using various commands. I'm not going to go into how to do the SCP option. All right. One other thing that might be useful now that we're in the Linux is I can run this lsblk command. This shows me on my particular switch how much disk space is available in each of the partitions. I can also use df -h. The -h puts this output in human readable form. It shows how much is used and how much is available on each of these different file systems, along with a percentage used, which is also important to have. In Linux, we also have the ability to look at the processes that we're running. So this is the top command, very commonly used by Linux administrators. It shows just how much CPU is being used, other information about how much memory is being used. So memory and CPU are probably the two biggest indicators of the health of a system. If any of these are approaching 100%, you've got some real problems. So you hit Control-C to get out of that command. I can also look at interfaces. Actually we can use two different ones, IP-A shows you all of the interfaces. Now, there's a pretty close linking of Linux to the network operating system, which is PicOS. You will see quite a few different links. Loopback is pretty standard on all Linux systems. Ethernet 0 is our out-of-band Ethernet interface. And then we also have a lot of these down here, all these different VLANs. These do correspond to the VLAN interfaces that we have set up. So if I was to go out and look at my configuration, I could go find this 13.9 and I'd know which interface VLAN 5 corresponds to. So I've already jumped out of the Linux. I ran a command called show VLAN interface brief. And let's see here. So this one here, 10.226.13.9, matches up with VLAN 4094. So these numbers, VLAN.5, is not a direct match to the VLAN number. So you might want to just put this table. These don't change. This was just the 5th VLAN that we had defined on the system, more than likely, and that matches up to 4094. This comes in handy when you want to do a TCP dump, when you want to collect packets off of the system. So let me get back into the Linux, start shell sh. Now I can do this command here, TCP dump -i, and give it this interface. I think it's going to be this one. It might be 22. Let's see. So we do VLAN 5. And then I could actually dump this somewhere, or I can just have it, hold on a second. Let's see here if it's 22. Now, so I'm going to have to do a sudo in order to execute that command. And there we go. We're listening on VLAN.5 for any packets that go across. So I've gone ahead and started a ping in the background so that we'll actually have traffic over our peer link, and I'm going to do a TCP dump on that VLAN 5 interface, and you will see that we are getting our echo request and echo reply. So that does show that indeed we can capture packets using the Linux. So you can see I went ahead and I killed the ping, and I've restarted my TCP dump, and it's listening and it's not getting any packets currently. So this is something I can leave like this. I could also run it. I could also run the TCP dump where I'm filtering on a particular type of packet using the -s command, and then writing it to a PCAP file, which then I could later transfer to my local workstation and view through a program like Wireshark. So one other thing I can show you is once you get into the Linux prompt, you can then do pings to any of the interfaces. You can see that I've got, oh gosh, there we go. There's a ping right there. So I can ping to 13.10. That's the other side of my one of my VLANs. I can also use any Linux commands, a ps -ef to show all the processes. I can do an ls, which will show me anything on the system, any files. I can use cat to show the contents of a file. I can use more, tail, all the different Linux commands that you may be familiar with. Alright, well, if TCP dump doesn't provide you the information you want in looking at a particular VLAN or an interface that has an IP address configured on it, you can always utilize port mirroring. So how do we set port mirroring within a CLI? So we're going to go into configuration mode. Alright, there we are. We're in configuration mode. Then we're going to select an interface. So the best way to look at an interface is do a run show int brief. Shows us all the different interfaces. We have an interface here. Let's go ahead and look at this one, and we're going to mirror it over to. So we're going to take the data coming out of 1124 and we're going to send it over to 1121, where ideally on 1121 we would have a device running Wireshark that's able to capture all of the data. Now, do pay attention to the speeds that are here. It is possible to go ahead and grab data, do a port mirror from a 10 gig interface to a 1 gig interface, because typically that's what a device would be running at, is 1 gig, and that's where your Wireshark would be. So you can do that, but do be aware that you could overrun the port and drop packets. And the first priority of a switch is to switch and route. So when you're doing port mirroring, and if you have a situation where you've got a denial of service attack or just a lot of information going through a given port, the switch will prioritize switching and routing packets over making a copy of those packets and sending it to a switch port. So set interface, Ethernet switching options, analyzer, and we give it a number. We can call it 120. We say input, ingress. That's ingress or egress, right? I can choose either one. So either this is the traffic coming into that gigabit interface or going out of. So it's bidirectional. So you would actually, if you want to get the ingress and the egress, you would have to do 2 commands. And we're going to be looking at, in this case, TE-1/1/24. Now let's go ahead and create one for the egress. And now we have to tell it where are we going to send that data. We're going to set interface, Ethernet switching options, analyzer, and we tell it to use the same one, output. And then we specify the output port. 22 is what we wanted. That's where the analyzer is going to go. We hit commit. Well, if these were not members of lags, then it would work fine. So on this particular device, we can't do it because we don't have everybody's part of a lag. Let's go ahead and just show that real quick. So run show aggregate interface, aggregate Ethernet. And you can see that quite a few different ones. So after a little bit of investigation, it looks like we've got port 1 that would be available. So I'm going to go ahead and delete this command. Okay, now I can go ahead and commit. We're missing the other output. So once we've committed, let's go ahead and set this one to be 1. Now we should be able to commit it, and we can. All right, now that we've set it up, we can look at the status of that port by doing run show analyzer 120. And it shows us that our ingress interfaces and egress are the same port, and we're outputting it into port 111. So we would attach our Wireshark or our analyzer to port 111. Thank you.